Good morning students. Today we are going to see about carbon dioxide transport. The carbon dioxide is transported in three forms as bicarbonate. It is 70%. As carbamino compounds, that is combined with hemoglobin, that is 23%, and as dissolved form 7%. Now carbon dioxide which is produced from the tissues, it has to be transported in the blood and it has to reach the lungs where it is exhaled out. So we start with the tissues. So what happens in the tissues? So in the tissues, so what happens in the tissues? Carbon dioxide is produced from the tissues and it enters the blood and it enters the RBC. So inside the RBC, okay, inside the RBC, this is the shape of RBC. The carbon dioxide is entering inside, combines with water, forms carbonic acid, which dissociate into H plus and bicarbonate. So these sequence of reactions are catalyzed by the enzyme carbonic anhydrase. So RBC is rich in carbonic anhydrase. So these reactions taking place, and this H plus ion which is produced from the carbonic acid, it combines with hemoglobin. Because the hemoglobin is now free to get attached to H plus ion, because the oxygen from the hemoglobin will be already taken by the alveolar tissues. Okay, so now this hemoglobin is attaching with the H plus ion and the bicarbonate is leaving the RBC for exchange another anion which is called chloride, and this was done by an exchanger called anion exchanger or band 3 protein. The name of the protein is band 3 protein. So this protein exchanges bicarbonate and chloride ion. So this shift of chloride is called chloride shift. And the venous blood, so this is taking place in the venous blood. So the venous blood, the chloride content is lower than the arterial blood because of the shift of the chloride. Second point, the chloride is osmotically more active ion, so it imbibes water by osmosis. So the RBC get little bigger in size in the venous blood. So the hematocrit of the venous blood is 3% greater than arterial blood. So hematocrit will be 3% greater than the arterial blood because of the osmosis and big sized RBCs. So this was called as the chloride shift. And here another effect is explained. Due to the entry of carbon dioxide, there is unloading of oxygen is taking place, and this effect is called as Bohr effect. It's called as Bohr effect. So Bohr effect is the carbon dioxide, increase in the carbon dioxide either in the RBC or in the blood, it causes unloading of oxygen from the hemoglobin. So this is called as Bohr effect. And this chloride shift was discovered by a scientist called Hamburger. So it is also called Hamburger phenomenon. So this was explained as Hamburger phenomenon. Now this blood, it is venous blood, now it is going to the lungs. Okay. So what happens in the lungs, at the level of lungs? The reverse process taking place in the lungs. In the lungs, carbon dioxide will be, so oxygen will be entering into the RBC in the lungs. So in the lungs, oxygen is entering into the RBC and it combines with the hemoglobin. So the H plus ion will be separated from the hemoglobin and the H plus ion combines with bicarbonate. Now the bicarbonate will be entering into the RBC and chloride will be leaving the RBC in the lungs, in the pulmonary capillary. And now this bicarbonate combines with H2CO3, carbon forms H2CO3, that is carbonic acid, and which dissociate into H plus and H2O and CO2, so water and carbon dioxide, and now this carbon dioxide is given out. Okay, so this process is like reversal and it is called as reverse of chloride shift. And here again the entry of oxygen, okay, the oxygen entry causes unloading of carbon dioxide, and this effect is called as Haldane effect. So increase in oxygen causes unloading of carbon dioxide. So oxygen, when it enters, combines with hemoglobin, so H plus is dissociated from the hemoglobin. And it combines with bicarbonate, which is entering into the RBC, and this bicarbonate combines and forms carbonic acid, which dissociates into water and carbon dioxide. Now this carbon dioxide is given out to the lungs. So this was called as reverse of chloride shift or Haldane effect. To sum up, in the tissues, chloride ion will be entering into the RBC. In the lungs, pulmonary capillary, the chloride ion will be leaving the RBC. That is one point. And all these reactions are taking place in the RBC because of the presence of the enzyme carbonic anhydrase. So RBC is rich in carbonic anhydrase. And we saw two effects. One is the Bohr effect in the tissues, other one is the Haldane effect. What is Bohr effect? Bohr effect is entry of carbon dioxide, increase in the level of carbon dioxide, or decrease in pH, because carbon dioxide increases, carbonic acid will be increasing. So that will cause us unloading of oxygen, that is Bohr effect. And Haldane effect, increase in the oxygen causes unloading of carbon dioxide. And this correlation is called as Hamburger phenomenon. Thank you.